These are solutions to Melham's exam 4 for Math 225 at CSM. Okay, question 1, 300 degrees multiplied by pi over 180, reduce 5 pi over 3. Number 2, you're given x is equal to 4/5, x squared plus y squared equals 1. So x squared is 4/5 squared plus y squared equals 1. 4/5 squared is 16 over 25 plus y squared equals 1. Subtract 16 over 25. Y squared is 9 over 25. Y is equal to 3/5. We're told that we're in quadrant 1. So the ordered pair is 4/5, 3/5. So sine of theta is the y coordinate 3/5. Cosine of theta is the x coordinate 4/5. Tangent of theta is the ratio of these two. 3/5 divided by 4/5. Cancel out the 5s, 3/4. And reciprocate, reciprocate, reciprocate. So cosecant of theta is 5/3. Secant theta is 5/4. Cotangent theta is 4/3. Number 3, 17 pi over 6 is 12 pi over 6. The reason why I say 12 pi over 6 is that's 2 pi. We'll go around the circle once and add another 5 pi over 6. So we land in the same spot, coterminal, with 5 pi over 6. That looks like the y coordinate is a half, which means the x coordinate is negative radical 3 over 2. Okay, so the cosecant of 17 pi over 6 is 1 over the sine of 17 pi over 6. The sine of 17 pi over 6 is 1/2. 1 divided by 1/2 is 1 times 2 over 1, or 2. 4, prove the identity. There's nothing to do on this side. Okay, secant is 1 over the cosine, so you have cosine A times 1 over cosine A minus cosine A. Distribute, you have 1 minus cosine squared of A, which is equal to sine squared of A. So they match. Number 5, triangle ABC. AC is 4, BC is 3. The hypotenuse AB is 5. Just do a little bit of A squared plus B squared equals C squared. Okay, so BC squared is 3 squared is 9. AC squared is 4 squared is 16. 9 plus 16 is 25. That's AB squared, so AB is 5. Okay. So the sine of A, opposite over hypotenuse, 3/5. Cosine of A, adjacent over hypotenuse, 4/5. Tangent of A is 3/4. In case you were wondering, yes, the answers here are exactly the same as the answers here. Okay, so the reciprocals are the same also. Okay, 6, secant of 5 pi over 3. So 5 pi over 3 is over here. This is pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Okay, it looks like x is halfway. So the x coordinate is a half. Half is always paired with radical 3 over 2. We're in the 4th quadrant, so negative. So we're asking for the secant, which is 1 over the cosine of 5 pi over 3, 1 divided by half, 2. And in case you're wondering, yes, that calculation is exactly the same as this one. So there's a lot of repetition. 7, draw the graph of y equals sine of x, and then use the graph to determine the first 2 locations in the first quadrant where the y coordinate is 1. Okay, so here's 1 period, and we go up to here. Okay, so y coordinate is 1 here and here. So we have pi over 2 comma 1 and 5 pi over 2 comma 1. Okay, number 8, amplitude is 3. Period is 2 pi divided by b. 2 pi divided by 2 is pi. Shift pi over 4 to the right and 1 up. Amplitude 3. Period is 2 pi divided by 2 or pi. Shift pi over 4 right, 1 up. So the range, normally for a cosine or sine function, the range is from -1 to 1. Amplitude is 3, so I multiply by 3. And then a vertical shift of 1 means I move the graph up 1 unit. So 3 times -1, 1 is -3, 3 plus 1. So -2, 4, with a midline of y equals 1. Okay, if I had no horizontal shift, since the period is pi, I would complete 1 period between 0 and pi. But since there's a horizontal shift of pi over 4, I add pi over 4, and my new x values to complete 1 period is from pi over 4 to 5 pi over 4. So here's my graph. Maximum of 4, minimum of -2, midline of y equals 1, pi over 4, 5 pi over 4. And I'm doing a cosine, which goes maximum, midline, minimum, midline, maximum. So there's the graph that I want. Okay, number 9, amplitude is 5. Okay, the B is pi over 2. So period is 2 pi divided by pi over 2. If I divide by pi over 2, I multiply by 2 over pi. Pi's cancel out. You have 4. Okay, so 1 period is 4. On the graph, they tell me to go out to 8, which means I'm graphing 2 periods. All right, so my range, which is normally from -1 to 1, but since the amplitude is 5, I multiply by 5. So my new range is from -5 to 5. And 1 period is from 0 to 4. So here's 1 period. Sine starts at midline, max, midline, minimum, midline. Okay. But they told us to go out to 8. So copy and paste this over to here. Same thing. Max, 0, minimum, 0. So there we go. Okay, finally, number 10, cotangent parentheses x minus pi over 4. Take the regular cotangent function, shift pi over 4 to the right. So here's 1 period of the cotangent function from 0 to pi. It's a decreasing function. Okay, undefined, 1, 0, -1, undefined. Shift pi over 4 to the right. So 0 moves over to pi over 4. And pi over 2 moves to 3 pi over 4. Pi moves over to 5 pi over 4. And just draw the same thing right there. Okay, and you raise it up again so you can see it. But this is the solutions for Melham's exam 4, math 225. And just so you can see a little bit better, raise everything up. So hopefully you can see it better if you need it. Okay, the top there is a continuation of problem 8. And there's 9 and 10. All right, so that's the solutions for exam number 4 for math 225.